गुड मॉर्निंग। आज हम क्लासिकल इलेक्ट्रोडायनेमिक्स में यूनिट फर्स्ट दैट इज रिलेटेड विद द इलेक्ट्रोस्टैटिक्स में स्केलर पोटेंशियल एंड बाउंड्री कंडीशंस फॉर इलेक्ट्रिक फील्ड एंड द पोटेंशियल के लिए डिस्कस करेंगे। सो ऑन द लास्ट टर्न वी हैव प्रूव्ड दैट द कर्ल ऑफ द इलेक्ट्रिक फील्ड इज जीरो, दैट द कर्ल del cross E equal to 0, where A is the electric field strength at the field point R due to the charge Ri. So we can write E equal to the 1 by 4 pi epsilon naught sigma I equal to 1 to n Qi R minus Ri divided by R minus Ri power cube. Here we have considered that the electric field is calculated at the point R, that is called the field point or the observer point, and the Ri the source point. The del cross E shows that the electric field is irrotational, and so it may be expressed as a gradient of the scalar functions, as earlier we have write. So the Er equal to minus gradient of the phi r. Here the negative sign is used for as conventionally, and the phi r is called the electrostatic potential. Now we have to calculate the scalar potential phi r by using this expression of the electric field. So we know that the electric field E equal to 1 by 4 pi epsilon naught sigma Qi multiplied by the Ri, R vector minus Ri vector divided by R minus Ri power cube. And we know that in sides I have write the gradient of the 1 by R equal to minus R vector by the R cube. How we can calculate? We know that R equal to the xi plus yj plus zk, R magnitude, or you can write also R equal to the x minus xi in terms of the source and the point, x minus xi I cap plus y minus y I jk plus z plus zi minus power kk. So the R magnitude is equal to x minus xi k square plus y minus yi square plus z minus zi k square power whole power half. So del of the 1 by R. Del means I cap del by del x plus j del by del y plus k cap del by del z of which x minus xi square plus y minus y square and so on power half minus half. And to calculate its the first functions differentiation with the respect to the x, so we can write minus 1 by 2 into the 2 of the x minus xi and that the whole bracket power minus 3 by 2. So in short form we can write sigma I x minus xi by the r cube, or we can write minus r vector by the r cube. So gradient of the 1 divided by r minus ri magnitude is equal to the minus of the r minus ri divided by r minus ri power 3. So the E equal to 1 by 4 pi epsilon naught Qi minus of the gradient of 1 divided by r minus ri magnitude. We can take the gradient outside, and this is gives gradient of the 1 by 4 pi epsilon Qi multiplied by the 1 divided by r minus ri dash. So we have earlier write that E equal to minus gradient phi. So on comparison of equation fourth, we can obtain phi r equal to 1 by 4 pi epsilon Qi divided by r minus ri. Definition of the electrostatic potential. How can obtain the definition of it? If we suppose that at the reference point potential is 0 and that is at the infinite, so Er equal to minus gradient phi, we can write reference point to the r e r dash dr dash line integral of this one minus gradient of the phi r dash dr dash, and this is the d phi. How? Gradient phi r dash and dr equal to, we can write I cap del by del phi by del x, j cap del phi by del y and so on, plus dot dxi dyj dyz. और इसको मल्टीप्लाई करके देखें तो del phi by del x dx, del phi by del y dy, and this is d phi. So these two can be written in form of the d phi or integrations. We can obtain phi r dash equal to minus reference point to the r e r dash dr dash. So it is its definition is that the electrostatic potential at a point may be defined as in the work done by the external source against the direction of the field in carrying a unit positive test charge from some reference point to the point under the consideration. कि इनफाइनाइट से या किसी पर्टिकुलर पॉइंट से रेफरेंस पॉइंट से हम किसी पॉइंट पर आने पे जितना वर्क डन होता है बाय एक्सटर्नल सोर्स, सो अगेंस्ट द डायरेक्शन ऑफ द फील्ड, then this is the equal to the potential at that point. So reference point is considered the infinite and where the potential is 0, so we can write phi r equal to the minus of the infinity to r e dot dr. In place of the e we can write 1 by 4 epsilon naught q r vector by the r cube, and this is we can write like this one, and this is again the same conditions, phi r equal to 1 by 4 epsilon naught q by r. Now potential physical interpretation of the potential. What is use of it? What is the interpretation of this one? Let us consider the work done on a test charge q in the transporting it from one point A to the another point B in the presence of an electric field EW. We can write force at the point equal to QE. So work done in moving the charge from A to B. You can write W equal to minus E to B F dot dl equal to the minus q A to B E dot dl. Negative sign indicate that the work done on the charge against the action of the field. So E equal to minus del phi. Earlier we have write, so W equal to q A to B del phi by dl, and this is d phi. Again the same conditions we obtain again. So this is the W equal to q phi B minus phi A. This so that the q phi is the potential energy of the test charge in the electrostatic field. To prove the electric field is the conservation in nature, we know that A to B del E dot dl equal to the minus phi B by pi A, and the B to A E dot dl for minus phi A by the phi B. So the sum of these two we can write for the closed path E to B dl equal to 0. Surface distribution. Next, the surface distribution of the charges and the dipoles and discontinuity in the electric field and the potentials. So to calculate the electric field at a potential due to the surface charge distribution, we have to use the Gauss law, and using boundary conditions we can use boundary condition at interface of the two layers. Let sigma is the surface charge density over a surface. The electric field and the potential can be correlated on both sides as follow. By the Gauss law we can obtain the first boundary conditions. Let us consider a conductor sheet whose the electric field is the E2 on the top above the layer and the E1 is on below, and the n cap is the perpendicular directions of the area and sigma charge density. So Gauss law we know that for the closed path the surface integral E dot dA equal to q by f naught, q को हम लिख सकते हैं sigma into A. If the size of the layer is very small, t is 10 to 0, just like that, the pillbox is, this one is 0, then we say the E perpendicular above A minus E perpendicular below equal to sigma A by the epsilon naught. So E perpendicular above minus E perpendicular below equal to the sigma by epsilon naught. So the normal component is discontinuous for this one. If there is the charge distribution on the surface, normal electric field is discontinuous, but if the sigma is 0, then this is the following the continuity. Next, the tangential component of electric field. We know that the electric field is a conjunctive field, so the E dot dl equal to 0. For the closed path it is 0. So for the pillbox, length is sides on the L and the thickness is T. If the T is 10 to 0, then we can write E parallel A above L, इसको हम पॉजिटिव मान लिया, बिलो की डायरेक्शंस को हमने नेगेटिव मान लिया, तो दोनों का क्लॉज पाथ के लिए 0 हो जाएगा. सो वी कैन से E parallel above equal to E parallel below. So it is the continuous. Third boundary conditions for potentials. The potential difference between the layer A and B, we can write phi above minus phi below equal to the A to B E dot dl. So we can write if the t equal to 0, RHS is 0, integral with the 0 h we have considered. So above equal to the below, and the gradient of the potential last E equal to minus del phi होता है. So E above minus equal to the minus del V above, and the E below perpendicular equal to the minus del of the V below. दोनों का डिफरेंस कर दें, ई परपेंडिकुलर अबव माइनस ई परपेंडिकुलर बिलो, जो हमने कैलकुलेट किया था सिग्मा बाय एफ नॉट एन कैप. So substituting the value of these two, differential of this one, gradient of the potential, that is the del V above by the del n and then del V below by the del n equal to minus sigma by f naught. So this is discontinuous at this one. So these are the four boundary conditions for it. Thank you.